after seeing the day one lesson and hearing from friends that trig identities are so tough, you might have been unimpressed because day one is just like intro to identities. I won't lie. Some crazy stuff's going to happen here. And it really tests your ability to do algebra with trig functions. Here's your toolbox of things that you could use. Cosecant, secant, and cotan, hopefully you already know, but new to you on Friday was tan is sine over cos, and with that, cotan is cos over sine. This is a better version of the toolbox. I built the other one. This is like the final version of it. And also sine squared theta plus cos squared theta equals 1, but that can be used in rearranged form. All I've done is rearrange in those other two versions. Everything else that's new about identities today will come out in the examples. You ready? It's wild. Some wild examples coming up. Prove the following identities. Okay, so one of the things that came out of Friday's lesson was the first move is to go left side. After bragging about my board, I immediately have the same trouble I was having. Let's take a look here, see what's happening. There we go. Left side. 1 plus cotan theta over cosecant theta. And, well, I know something maybe that you don't, but you don't have to know it. But it's the only reason I've gone over here and gone, I put sine theta and cos theta over here. And I'll let you in on my little secret. I can tell by looking on the right side, there's not much I can do. It's already sine theta and cos theta. There's no fractions. There's no brackets. There's nothing really that can be done about the right side. All the work's going to be done on the left-hand side of this particular identity. And without getting intimidated by the fractions, what do you see there besides my mistake in my writing? Goodness gracious. Get rid of all that. Fix that up. Cosecant theta. There we go. Now it's written properly. What do you see on the left-hand side? What can I accomplish on the left-hand side? Let me phrase it another way. On the right, I see sines and coses. That gives me an indicator. I better get to all sines and coses. That was one of my tips from Friday. If you see any sine and cos, go to all sine and cos, and it's always possible. I'll immediately change these all to sine and cos. What does cotan become? You can pick at your trig toolbox. Cotan can be 1 over tan. Not a bad choice. Better yet, cos over sine. That's what cotan is. And that can look really scary. It's okay if you're like, oh, fractions inside of fractions, what a big mess, I'm really scared. I know, that's why you're here today. It's for me to try to explain how we're going to deal with these crazy fractions. Because actually the trig here is not the really scary part. You need one of those? The trig is not the really scary part. It's the fractions that are the real problem here. How about cosecant? Did I give you enough time to look and see what cosecant is? Cosecant, 1 over sine.
How do I get that on a calculator? I was actually going to ask because
There's no cosecant button on the calculator.
no, I was going to find the with the line through it.
You'd never.
Data.
You'd never type that on a calculator.
Really?
It's like X. There's no X button on your calculator because you don't type in X. Okay? You got to know what to do with these formulas. Now, there is choices here. So I'm going to show the fraction work. And at the end, hopefully, you're listening carefully to what I say next, because I can show a really neat way to handle this question. I can handle the fraction in here really neatly. To do this with fractions, I've got to first think of as 1 over 1. Do you remember that move from fractions? When you didn't have a denominator, you gave a denominator 1. And the numerator wants me to add two fractions. What do I need to add two fractions? Ben? Common denominator. And so the common denominator here will be 1 times sine theta, those two things put together. Now, this one already has that common denominator. And I know this really confuses people. Oops. Especially when I write it incorrectly. But just write it down and stare at it for a second and see if you see what I did there. To that first fraction, because it's fractions we got to talk about. That's not trig. That is not trigonometry that I did there. I just got a common denominator. I went, okay, I want sine theta in the denominator. So I made 1 over 1. I times top and bottom by sine theta. And if your fractions are just so-so here, they're going to get exposed. That's the honest truth of why people hate trig identities, because it exposes what your fractions, how good you are with your fractions. Because now there's no calculator available here. I can't. Some of you have been cheating with your calculator and going, oh, 1/2 plus 1/4, I'll just type my calculator. I don't remember how to do fractions, but my calculator knows how to do it. That's all going to get exposed now by identities. So now I can add the two fractions in the top and make it into one fraction, and that's way better. That's the numerator. But I'm going to do something else that's very helpful. In fact, I'm going to draw a line over here because I know I don't have to do any more work over there. When there's, I'm going to say this sentence 3 times and I'm going to bore you with it. When you have fractions inside of fractions, write them as division instead. It's way less confusing. Instead of having divide by 1 over sine theta, write it as divide by 1 over sine theta. That is way, way less confusing. Because we know how to divide fractions. Does anyone remember how to divide fractions? Flip and multiply. So what happens here is this becomes sine theta plus cos theta. That's all over sine theta. And then that's multiplied by sine theta over 1. And then hopefully you'll see my hint here. Well, what's going to happen next? I'm going to switch to orange there. Do you see the cancellation? The signs go. Finally, that goes with that. And I'm left with sine theta plus cos theta. Now, I know when you're watching this, you're going, oh, you're acting like this is so easy. I'm a little confused about everything that's happened there. I know it's going to be your fractions. That is the main problem. Say, oh, identities are so tough. I don't think they are. Fractions are so tough. Being able to do common denominator and add fractions when the fractions are made up of sines and coses, that's really challenging. And I'm exaggerating a little bit. Obviously, it's because of trig that your fractions are getting exposed here. Is it done, though? If you look now, I think you'll see therefore left side equals right side. Therefore, true. So if someone were to ask me on Friday after the lesson, they say, well, what do you still have to teach us? The first thing I would have said was fractions. Yeah, because some of your fractions probably have got a little rusty, and so now we're going to need it. So what did I do with the fractions? I knew if I had to add fractions, I need a common denominator. If I didn't have a denominator, I put it over 1. And I'm going to say it 2 more times. When you got fractions inside of fractions, write them as divide. You'll find it less confusing if you write it as divide. If you found that pretty easy but long and boring, I'm probably not talking to all that many people at this point. Most people probably have to practice their fractions. But if you found that pretty straightforward but long and boring, watch this. I could have, way up here, seen what was going to happen with the fractions and saw that there was sine theta in both the top and bottom. And I could have right then multiplied top and bottom by sine theta. If I did that, I could have jumped all the way to here. But don't do that until you really get it. It is a tough step to understand, but boy, does it shorten this down. It's one of the best tricks in math is to multiply top and bottom by the same thing. And this, I'm multiplying top and bottom by the denominator. The denominator, sine theta times 1 over sine theta, that cancels. Sine theta times 1 is sine theta, and when I multiply sine theta times this one, it just becomes cos theta. Very smooth algebraic move. Okay. But I pause for questions. Do you need more time there? I believe it's all examples today, isn't it? 1, 2, 3, 4, 5. My brain tells me I have 5 to do. I have 5? And then get your marks to you from your test. Oh, just 4 to do. Why did I think I have 5? I don't know. Todd's losing a little bit. Look at this thing. Woo. Left side. Right side. You can get a little creative with your left side, right side here. I'm only going to leave that much room for right side. There's not much I can possibly do over there. And this is what I was trying to say on Friday. Start with the more complicated side. I'll get to the right side. But for now, I'm going to go over and work on the left side and go after the more complicated side. And let's just say a little bit more about fractions here. Because at the end of that last example, you could have been left with the the question, why did fractions even come up in all this? And here's my answer. My answer is, in identities, if one side is all one term, which this is 2 secant x, and the other side is 2 fractions, you got no choice. You're going to have to add the 2 fractions. So then here it comes. What do I need? Common denominator to add 2 fractions. So my first fraction lesson, my first of the scraping the rust off your fractions is, if we're going to add or subtract fractions, we're going to need a common denominator. And the common denominator doesn't have to be, but is usually just those 2 denominators multiplied together in these ones. Doesn't have to be. But that's usually what you're going to do. So I'm going to multiply this fraction by that denominator, top and bottom. I'm going to multiply that fraction by this denominator, top and bottom. Essentially, all I'm doing is multiplying by 1. If you want to, in the future, if you're thinking of being a teacher, that's one thing I'd like to encourage people to get through when you're teaching fractions. Like, I'm not doing anything to the fraction. I'm just multiplying top and bottom by what I find convenient, which is 1 minus sine theta. Sorry, I'm saying theta, but I can see it's x, so 1 minus sine x. And I'm multiplying this one by 1 minus sine x top and bottom. And this one instead, I'm going to multiply by 1 plus sine x top and bottom. And the only thing I'm trying to accomplish there is to get a common denominator. So I'm going to multiply the numerators first. Sorry, the denominators first to convince you I've accomplished what I set out to do. This denominator is now 1 plus sine x times 1 minus sine x. And this denominator is now the same thing, well, written in the other order. But it's the same thing. 1 minus sine x, 1 plus sine x. And I got some work to do, but at least now it'll be a common denominator. I can add these 2 fractions when I get to it. So, let me write in. I don't want to use cancel orange. I want cancel orange to stay as my hint thing. So I'm going to use, ooh, little Easter purple here. The numerator of this one has to distribute, and the numerator of this one has to distribute. That can be upsetting if you want. You'd be like, ugh, what a mess. This I get cos x minus sine x cos x when I multiply out that one. And this one I get cos x plus sine x cos x. All I've done is distribute in the numerator. I just multiplied those together. And again, if this is all starting to run together on you, yeah, I know, your fractions, if your fractions aren't fresh here, this is going to take a little while to get used of doing trig with fractions in it. Can I just get sidetracked here, though? I just want to have a little thought bubble here. Let's say your grade, I don't even know what grade it is, where you first learned fractions. I think it's like grade 6, maybe, grade 7 when you first see these? Grade 5, maybe? Okay. Let's say I had 3/11 plus 2/11. What would you tell your little grade 6 cousin that they should do with these fractions? And this isn't me talking down to you. This is me. There's a lot of math we put in your brain here. What do we do to add fractions? What happens here? Ben, add the numerators. The top is 3 plus 2. But what about the denominator? It's still 11. That'll mess you up in all this. That's not what you do when you're multiplying. Multiplying, you multiply the tops, multiply the bottoms. Here, you just add the tops and keep the bottom the same. So I'm going to add the tops. Just look at those numerators for a second, because this is where some people would give up on this question. About here they'd go, it's too much for me. Well, watch what happens. Cos plus cos. Cos plus cos is 2. And for the first time, the lights come on and go, 2. You're like, oh, I'm starting to build some confidence here. I must be on the right track. I got a 2. Cos x. But look at this mess. Negative sine x cos x plus sine x cos x. Those cancel out. So trig identities, this happens a lot. Just when someone asks me a question is the exact time they were almost home. They just had to keep going here. And then keep the denominator the same. And if that was a test question, you could happily go home and say, well, it was 4 marks. I got at least 2 of the marks. I did a bunch of the work. I'm not going to get 0 on this. It's good work. Here's my next big piece of advice. The left-hand side had 2 fractions. The right-hand side only had 1. Those fractions had to get together. That had to happen. Next. The right-hand side doesn't have any brackets. The left-hand side does have brackets. Potentially, the thing to do is distribute those brackets and at least get the brackets gone. So all I'm going to do now is distribute out the denominator and go, okay, let's see what I get when I distribute out the denominator. 2 cos x over, I'm just distributing, just doing FOIL here, 1 minus sine plus sine. Let me just leave that for a second. I'll let you stare at it. Convince yourself that that's right so far. I'm not done with the FOIL. 1 times 1 is 1. 1 times negative sine is negative sine x. Sine x times 1 is positive sine x. But what's positive sine x times negative sine x?
Negative.
Negative sine x, but it was multiplied by itself. Squared. And if you're right with me, somebody's jumping up and down on the bench now. To get involved here, I'm just going to tidy that up a little bit and then Kyle the question. 2 cos x over 1 minus sine squared x. Listen, friends, by Thursday, 1 minus sine squared has to set off bells. You're like, 1 minus sine squared. 1 minus sine squared. Where do I see 1 minus sine squared? Somewhere there's 1 minus sine squared. Okay?
I understand it, but like, I don't know
Which
when
sign?
you're adding it. Oh wait, one's negative and one's positive.
Yeah, negative sign
Oh,
plus sign is 0.
No, like the very top one. Not the very top one, the second top one.
Here?
Yeah.
Which sign?
Because you added those together, right?
Right, so I just kept the denominator the same. Same as 3 11ths plus 2 11ths, I just kept the denominator. I didn't have to change anything.
The top part, the numerator.
Yes?
Like the signs, they canceled each other out. Right?
Negative sine x cos x, positive sine x cos x.
Oh, okay, that makes
They
sense.
added together, yeah?
But okay, then I don't get why when you did the second bottom one, like the negative and the positive to make the sine x squared or whatever.
Yes?
Why do you keep the you kept the sign both of them? So now there's like 3 or 4.
I foiled. 1 times 1 is 1. 1 times negative sine is negative sine.
Oh, it makes a lot of sense. Okay.
Sine x times 1 is 1. So there's 4 different terms that come out of there. The good news is 2 of them cancel. That often happens. Just when you think nothing's going to work out, something cancels. Did that give anyone enough time to find out what 1 minus sine squared is? Cos squared. Now, if you're annoyed by that, that's what, I understand the fractions are a big problem. But you see the problem of identities. I got to juggle fractions and FOIL and this new trig toolbox all at the same time and try and manage all this stuff. So if you look at your trig toolbox, 1 minus sine squared is cos squared. And I'll write some extra steps here, just in case this is all getting to be too much on a Monday. Cos squared x, this is what cos squared x really means. It's cos x times cos x. One of the coses cancels, and I get 2 over cos x. And that's, now finally I'm ready to talk about the right-hand side. Secant's 1 over cos. So 2 secant is 2 over cos. Left side equals right side. If that scares the bananas out of you, good. Some of you weren't scared enough last chapter, obviously, after marking those tests. Maybe a little fear will get you going here. But I paused for questions. Kyle had 2 good questions there. What questions do you have?
I have a
Kyle, question.
Actually. So like the cos and sine and stuff, like they all have like they're all equal in number, right? It's kind of just like a word for the number.
I think I know what you mean. Like cos x is all one thing. That's cos x. If I add another cos x, then I get 2 cos x. That's all one piece, yeah.
Can I just like what? Actually, that one makes sense. Cause I was just gonna say, cause like there's a decimal form of it, right? Or like if you just hit cos and then equal in a calculator.
You won't get anything. That's a little like hitting squared on the calculator. If you don't give it something to cos, you're not going to get anything. You can't just hit squared. You can do cos of 1, but x isn't 1. We don't know what x is.
I was just wondering if instead of using the word, you could use like the number for cos.
There isn't a number for cos.
Isn't a number.
Yeah, cos is a function, not a number. Well, like a lot like squared. Squared's a function. It does something. So without the number, I can't do anything. And in this case, I don't have the numbers. I've only got the variables. Questions? I'm not pretending like this is so easy. You're going to have to, there's only one way into identities. Write down the first question in the homework. Give it a go. Slam your head off it. Get a little bit of help. Try some of the steps. Try something out. Oh, well, going to get creative with my left side, right side again. Cotan theta. I'm not going to leave much room there. There's not much that's going to happen on the left side. Maybe 1 or 2 steps is all I can leave room for. The top I get cos theta plus sine theta cos theta over sine theta plus sine squared theta. And now the pressure's on me to say something very wise. or to do something very wise. Somebody erased my decoration at the back of this classroom. Does anybody remember what the decoration was that used to sit back here? Common factor. It's easy to believe in grade 11 and in grade 12 that Mr. Todd just likes to torture people with common factoring. It's the opposite of that. I know that math tortures people with common factoring, so I try and tell them about it a lot. This question, lots of good things happen if you common factor. Do you see the common factor in the numerator? What's common to both?
Oh, they're both signed. You just add them and make it 3x cubed or whatever.
No. In the numerator, what do you see that's common to both?
Cos.
Cos is in both, so I can common factor out the cos. And I'll deal with what's in the brackets in a second, because some people are like, well, how will I know to do that? I'm like, I don't have a guide for how you'll know for sure when to do that. But look what happens if I common factor the numerator. I get cos, and if you know cotan, cotan has cos in the numerator. Well, I'll get to that in a second, but it's like, this could be good. What common factor do you see in the denominator? I got sine theta and sine squared theta. It's got sine theta. At that moment, you're like, oh, this could be good. There's cos over sine right there. Maybe you go over here and go, okay, cotan is cos over sine. Maybe this is the right pathway. Maybe not. Some questions you'll try something and it won't bear fruit. That's annoying. I know that annoys math students. Like I did all this work and it wasn't the right thing to do. I'm like, yeah, I know. So, what's cos divided by cos in the numerator?
0, right?
No.
No, cos.
No. Don't guess.
1.
1. So I've divided cos out of that first one. What do I get when I divide cos out of the second one?
1.
It was sine theta cos theta. I've divided a cos out. Sine theta.
Oh, true.
Now, in the denominator, I common factor a sine theta. What's sine theta divided by sine theta?
1.
1. Oh, life's going good here. It's just setting up like, whoa. How about sine squared divided by sine? That is very difficult at this stage because mathematicians wrote sine squared as, with a little squared there. So when you need to, write it as sine theta times sine theta. That's what sine squared theta is. So if I take sine theta times sine theta and divide it by sine theta, I get sine theta.
Now I got a question.
Question.
Why wouldn't it just be sine? Like, why are we adding a 1?
Because there's 2 terms in the numerator. So common factoring means there'll be 2 terms in the brackets.
Oh, okay. Oh.
Then we're just done, right?
Yeah. You should really write the next line. It's awfully tempting just to stop there, but you really should write the simplified line. That one is either easier and possibly hard. Having marked these in the past, if this is out of 4 marks, I give a lot of 0s and 4s. Either people are looking for the factoring and they get 4 because it just plays out so nicely, or they're not looking for the factoring and they get nowhere. They just stare at this and go, I don't know what. Sometimes they replace sine squared with 1 minus cos squared, and that does nothing, and it achieves nothing in this particular case. And I can give them 1 mark for, like, well, that's a pretty good substitution, although it didn't accomplish anything. Yeah? I'm almost done, because I know something you don't know about this. Learning identities is a lot like learning to ride a bicycle. You can watch me bike around the park all day, and you're not going to get any better at riding a bicycle. You got to get into this stuff. Yeah? Our timing is good. We got today, 2 review days, and the test is until Thursday, so the timing is good. And I'll have your marks for you. I'll wake up call to some of you. There were some very good tests, by the way, and then a few people who did not dig trig.
Yeah, I saw.
Yeah? Clearly didn't do anything. Questions about that one? I'm going to leave common factor first up there on the board. If I don't, on test day, I'm going to write it back up there. Look for that common factor. There's a lot of common factor type questions that go pretty easy. As long as you know a common factor with trig, compare that to the last one. I think that's way easier than question 2. Question 2's got lots of fractions. So far, improve your fractions, watch for factoring. That's all. Rewinding. If on Friday you said, what are you going to teach us on Monday? Like, improve your fractions, common factor. That's all I've really taught so far, even though those are really difficult. Ben.
Can you just go through the factoring again?
Yeah. It's a great question, but I'm gonna do it differently than what you're asking, I think. I'm gonna. And I encourage you, if you're having trouble with common factoring with trig, to go back and do one of these just to get your brain warmed up on what has to happen. Because it's possible you got too good at common factoring to really think about what the steps are. Same with fractions. It's possible to get so good at fractions you forget what the actual steps are. What's common to 3 and 6? What number divides into both 3 and 6? 3. And then from a variable standpoint, I got an x squared and an x. I can pull out an x. But it's possible you're so good at this step you didn't think through what's happening. You just write down the numbers. With trig, you might have to think it through and go, what happens? And what's really happening is I'm saying, well, I'm taking 3x out of everything. So I'm taking 3x out of 3x squared. I took the 3 with me. And I took one of the x's. So there's only x left. Really what you're doing is 3x squared divided by 3x equals x. You're really dividing the term. So I encourage you to go back to that type of thinking here and go back to dividing. Using that type of thinking, what's 6x divided by 3x?
2.
2. So let me do one that's a little more similar to the one that we saw. What's common to both x and x squared? X. And when I take x out of x,
It's x.
what's left? 1, because I'm dividing. I'm going x divided by x is 1. That's where the 1 came from on the previous example. And then if I take x out of x squared, I divide an x out of x squared, there's still an x left. Some people that still bothers until they try to FOIL it. They're like, I don't know, Mr. Todd, I don't know if that's right. It doesn't seem like it should be right. So then the click comes in their brain when I go to FOIL this back out and go, what's x times 1?
X.
X. What's x times x?
X squared.
X squared. And sometimes people need to see the FOIL first or the distribution before they go, oh, I see where this is coming from. So let's go back to the trig example.
What's the point in writing the 1 at all then? If it's just like kind of pointless.
Is the 1 pointless, he says. Is the
No,
1
how you
pointless?
multiply and get the normalized.
And this is going to sound like I'm being sarcastic, but I'm not. I'm really trying to get through that there's a difference between 1 plus x and 1 minus x, okay? So watch this. 1 plus 5 and 1 times 5. 1 times 5 is 5. You're right, the 1 is useless when you're multiplying and dividing. There's no reason to keep the 1 there. But the 1 really matters when you're adding. 1 plus 5 is 6. So this 1 plus there, having the 1 out there, does change what's going on here because it's adding, not multiplying. Yeah? Good question. Ben, did that help at all?
Yeah.
Let's go back to the trig one and talk about what I did there. When I took cos theta out, oh, maybe it's the denominator that messes most people up. When I take sine theta out of sine theta divided by sine theta is 1. And then sine squared theta divided by sine theta is sine theta. Does that help a little bit?
Yeah, I had problems at the top.
Oh, more problems at the top. So do you see the cos common to both?
Yeah.
And then when I common factor the cos out, cos divided by cos is 1. Sine cos divided by cos is sine. Yeah?
I separated the sign.
Right, yeah. When multiplied, they're all one term. When added, they're two separate terms. It's good. It's really going to challenge your understanding of fractions and of terms and of multiplying and factoring and all those things. Now don't forget, before you panic, it's one whole day on those other identities, and I didn't sense a lot of stress in the room when I did the other identities. It's like, oh, not bad. So how many of these tougher ones are on the test? Well, there's a couple, but this isn't going to decide your life. There's going to be a couple tougher ones and a couple easier ones. So as long as you can get a couple steps in these at least, it's not going to completely ruin you. It's going to feel like that tonight maybe as you're trying to hammer away on these. And this one's really difficult. It doesn't look that bad, but it is. This is the toughest grade 11 identity going, because it's impossible to know even where to start. If I were to put something like this in the test without a hint, most people would not even be able to start. So I'm going to teach it a different way than I have in the past. I'm going to look and see that the denominator of 1 is 1 plus cos theta, and the numerator of the other is 1 minus cos theta. And try to remind you about the conjugate. The conjugate seems to bear fruit when you've got 1 plus something or 1 minus something. Multiplying by the conjugate seems to make things move around pretty well. So I'm going to multiply top and bottom here by the conjugate just to see what happens. And I'm sorry, but you've basically got to see this once before it makes any sense at all. Because something great happens in the denominator. 1 plus cos and 1 minus cos, they just belong together. Here, let me see if I can put a little harder on them. Anyone going future into trig? 1 plus cos, how's my heart? 1 plus cos and 1 minus cos, they just belong together. They're conjugates. When we saw this before, it was 5 plus root 2 and 5 minus root 2. Those things it just goes so well. Let me show you what I mean by that. When I multiply this out, I'm not going to multiply the numerator yet. Not because that I shouldn't do it, just because I really want to focus on what happens in the denominator, because this is really, really trig magic that happens here on the bottom. Here comes the distribution. 1 times 1 is 1. And this is conjugate multiplication. This is exactly what happens every time you use the conjugate. It looks bad. 1 times negative cos theta, negative cos theta. It's at that moment that you lose faith in Mr. Todd and in the conjugate, because you're like, what? This is making it worse. This is way, way worse. And I nod and smile and say, keep going, keep foiling. Cos theta times 1, positive cos theta. And then a half smile appears in your face as you're like, oh. Negative cos, positive cos. That's the magic of the conjugate, is those two middle terms are going to cancel out. So then the big question is this last term going to be helpful at all? And the answer is, oh boy, is it going to be helpful. Wait till you see what comes out of this. Cos theta times cos theta. Cos squared theta. And the world stops turning for a second as you go, oh, something's banging around in my brain about this situation. Now look, friends, this is very difficult to see what's happening. But as I look back and forth between these two, I'm pretty excited about the whole situation. This has got 1 minus cos. Now mine's got 1 minus cos. That's pretty good. Even if I didn't accomplish anything else, I've done a pretty good job here. I got 1 minus cos on both sides. However, what is 1 minus cos squared theta? I'll write all the other stuff. You take a moment, flip to the trig toolbox, and look around for 1 minus cos squared. Sine squared theta. And I'm almost home. I'll write an extra line here to really help you with sine squared theta, because that's not your fault that you find that difficult. The fact that we're writing sine squared theta like that is a little confusing. So let me just put that on there and highlight it. Ooh, let's see. Can I do highlighting easily on there? Yes. No? Maybe so? Pointer, my finger's on highlighter. There you go. Slowly but surely. If you're having trouble with sine squared theta, Write it as sine theta times sine theta. You'll see better what's got to happen. Can you see it? It just cancels. He sounded annoyed too. It just cancels. Tricks like that sometimes, like, oh, so it just cancels and it works out. Great.
Oh, and then what was
1 minus cos over sine theta. Left side equals right side. Therefore, true. Woo! It's tough to know what to do and why to do it in that one, let me tell you. I'm just practicing scrolling up here. There's another way to do this. It's the way I used to teach it. I just said, hey, these two denominators are different. Let's get the same denominator on both sides. And I sort of common denominator on both sides. And it works out too. Totally fine. But I wanted to show this other way to do it as well. So there's not always just one way to do these identities. Well, there's a guide at the bottom there to try and help you with your plan of attack. Simplify one set at a time, starting with the more complicated. That's, I'll put a question mark there. Usually, the more complicated side will be easier to work with. That sounds weird. Why would the more complicated side be easier to work with? Come in, Ian. Welcome. Grab a spot at the back. I'm almost done. Well, it's usually because the more complicated stuff has more stuff over there, so there's more things you could try. The simple side has nothing that can be done. Express tan, cosecant, secant, and cotan in terms of sine or cos. That one gets an exclamation mark. Yeah, that always bears fruit. And simplify algebraically using the Pythagorean theorem, common denominator, and factoring. That step acts like, oh yeah, just factor. Oh yeah, just use common denominator. You're like, that's really difficult. Here's number 4. How do you spell persevere?
Persevere.
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 Persevere. You've got to keep at this. On your way home tonight, stop by No Frills, get a box of Kleenex, put it beside your work. Don't cry. Write on your work. It smudges all your work when you're writing in pencil. Keep at it, keep at it, keep at it. It's a perfect advice for identities, and it's also a perfect advice for life. Just keep going. Don't tonight have an identity crisis and decide that math's not for me, I'm not going for university. An identity crisis.